let's look at this example for question. This would fall under the topic marginal analysis in calculus. Alright, it says given that the demand equation for a manufacturer's product is P equals 751 minus 3Q, and the cost function is C equals 7Q minus 0.3Q squared plus 150, where Q is the number of units, alright, Q as in quantity, and both P and C are expressed in dollars. Right, P represents the price. So this is really the price function, and C, the cost. Alright, what do they say? Determine an expression for the profit function. Alright, we want the profit function. The thing is, the profit, well, they use P up here for price already. What should we use for profit? Call it PR. Profit equals, it would be the revenue minus the cost. Alright, now, what's the revenue? Price times quantity would give you revenue. So let's multiply the price function by quantity, Q. Alright? So, revenue then would be 751 minus 3Q multiplied by Q, which is 751Q minus, this would be 3Q squared. Alright, that's revenue. Now, we know that the profit, PR, profit, would be the revenue, which is 751Q minus 3Q squared minus the cost. The cost is 7Q minus 0.3Q squared and 0.3Q squared plus 150. Alright. So when you remove the bracket, 751Q minus 3Q squared minus 7Q plus 0.3Q squared minus 150. Alright. So putting like terms together and so on, we have negative 3Q squared plus 0.3Q squared. This would be negative 2.7Q squared. Alright? Then the Q's now, we have a 751Q minus a 7Q would give us 744Q. What else? Minus 150. Alright, so there we have it. Our profit function. So in this case, PR would be negative 2.7Q squared plus 744Q minus 150. Good. That's what we have. Next thing, find the level of output at which profit is maximized. Let's erase some of these things here, and so that we have some more space. The level of output at which profit is maximized. Now, here you can see that this is a quadratic equation in Q, and the coefficient of Q squared is negative. So if you should plot a graph of it, it would look like this. Now at the maximum point, you have maximum profit. All right. Now, with the level of output at which profit is maximized. Now, at that maximum point also, the gradient at that point is 0, because when you draw a tangent to the gradient, you get a horizontal line. So what you need to do is to find the gradient function and equate it to 0, so that you locate wherever the gradient is 0. So let's do that. You find the gradient function by differentiating. So you differentiate PR with respect to Q. So d PR by dq equals, this would be what? Negative 2.7 multiplied by 2. This would be 2714, bring down the 4, carry 1, 2 2s from 1, 5. Negative 5.4 Q plus 744. Okay, that's it. And you make it equal to 0. Now, negative 5.4 Q would be, when you subtract 744 from both sides, you get negative 744. Then Q would be negative 744 divided by negative 5.4. When you divide, what do you get for that? So you have 744 over 5.4 give you 137.78. all right, 137.778. We keep the 3 decimal places until we reach the answer. So Q, find the level of output at which profit is maximized. Oh, that's it. So the quantity, the level of output quantity would be 130. Let me write that again, 137.778. If you were manufacturing whole number of items, you would write 138. All right. Now, calculate the price at which this maximum profit occurs. All right. So, in this case, now the price P equals 751 minus 3 times 137.778 equals, so what you do, you have 751 minus 3 times 137.778, and you get 337.7. Yeah, 337.7 then. So the price would be 337.7. Then they say calculate the maximum profit. The maximum profit. All right. Now, we want to know what the maximum profit is. Let's erase some of these things so far. Here now, profit, PR, the profit would be the revenue, the price times the quantity would be the revenue. So we have 337.7 the price multiplied by the quantity 137.778 minus the cost. So we minus 7 times 137.778 minus, let's do the minus, the sub. Alright, let's do the subtracting under here. So that's minus what now? 7 times the quantity 137.778 minus 0.3 times 137.778 squared plus 150, close bracket. Right, so our profit, our maximum profit would be, we have 137.7 times 337.7 times 137.778 equals 46527.63, 46527.63 minus what now? Let's work that part out. We have 7 times 137.778 minus 0.3 times 137.778 squared, so it's times 137.778 equals that, plus 150 equals, alright, we have minus negative, it's negative what? Negative 4580.39. 4580.39. This is going to be a plus. Alright, it will end up as a plus. So when you do the calculation now, what you're going to have is 46,527.63 plus 4580.39 equals 51108.02 equals 51108.02. Alright, 51108.02, $51,108.02. Okay, so there you have it for this example. I will see you in the next video.